Okay, gandang araw po. Today, we will be discussing regarding permeability or hydraulic conductivity sa ibang books. So, let's define permeability first. That is the property of soil or any material. It's just that here in geotechnical engineering, we're dealing with soil that permits or allows the passage of water under a gradient of force. And then we also have here transmissivity or transmissibility. Parehas lang po yung dalawang terms na yon. Yung transmissibility, mas gamit lang po yung term na yon regarding sa mga topics na mayroong vibrations. And then yung transmissivity naman, mas gamit yung term na yon kapag sa mga material such as porous soil. And that is the ability of an aquifer to transmit water through its entire thickness. So, yung permeability at transmissibility, they are somewhat related to each other. But then, to differentiate, yung permeability pertains to the velocity of flow of water through the total cross-sectional area of a certain soil sample. And then yung transmissibility naman pertains to the rate of flow of water through an entire thickness of an aquifer per meter width. So, permeability is the velocity, transmissibility is the rate of flow. Kailangan nyo munang ma-analyze yung permeability ng isang soil sample bago nyo makuha yung kanyang rate of flow or yung transmissibility. And then, we also have here all of the formulas used in this topic. Yung permeability, subdivided yan sa 4 na subtopics. Yung first one is the laboratory test in getting the value of permeability or hydraulic conductivity. Meron tayong dalawang method doon. First one is the constant head test, and then the second one is the falling head test. And then the second subtopic is the empirical relationship for hydraulic conductivity. Wherein, yung mga formulas dito, nakuha mismo yung mga formulas dito by the process of experiment and observation of a certain soil sample nung kinukuha yung kanilang values ng permeability. For the Hazen formula, Casagrande formula, Kozani-Karman formula, nagagamit mismo yung mga formula na to kapag yung soil sample na binanggit sa problem ay sandy soil. And then yung Samarasinghe, Wang, and Dernevich naman, nagagamit yung formula na to sa pagkuha ng constant or coefficient of permeability or hydraulic conductivity ng isang normally consolidated clay. And then the third subtopic is regarding the equivalent hydraulic conductivity of a layered or stratified soil. Meron din tayong dalawa doon. We have the horizontal hydraulic conductivity and then the vertical hydraulic conductivity. Yung figure dito, kung mapapansin nyo po, we have a 3-layer of soil here. And if this is our direction of flow of water, pwede ring pababa, that will be considered or under the vertical hydraulic conductivity. Pero kung nandito mismo yung direction ng flow papunta doon, that is under equivalent horizontal hydraulic conductivity. And then the last subtopic is regarding the field test in getting the value of permeability, wherein ang ginagawa doon is pumping of wells. Nahati namin sa dalawang klase. Depende mismo kung saan inilagay yung ating well mismo. Kapag meron tayo dong confined or unconfined aquifer. So, paano natin malalaman kung confined or unconfined aquifer? Well, yung aquifer, malalaman natin meron tayong aquifer doon kapag meron tayong layer ng soil doon na nakakapag-flow ng maayos yung tubig. Pero kapag hindi masyadong nakakapag-flow yung tubig sa layer ng soil na yun, that is considered as impermeable layer. Ngayon, kapag meron tayong aquifer na nasa ilalim mismo ng impermeable layer, that is under confined. Pero kapag yung ating aquifer ay nasa ibabaw mismo ng impermeable layer, that is under unconfined aquifer. Sa ibang problem, sinasabi na kung unconfined or confined. Pero pag minsan, hindi naman. Malalaman natin unconfined or confined aquifer tayo, depende sa klase ng soil na binanggit. Yung aquifer kasi, that is also sandy layer of soil. Dahil yung sandy soil, po pwedeng makapag-flow freely or maayos yung tubig doon. Pero kapag yung layer ng soil na binanggit sa problem is a clay layer, that is considered as impermeable layer dahil maliliit po yung voids ng isang clay sample of soil. So masyadong masikip po yung daanan, hindi masyadong makakapag-flow yung ating tubig sa layer na yun. So those are the topics under the topic of permeability. And for us to fully understand this, let's take an example first. So I prepared already here a series of questions. So first one, we have, for a constant laboratory permeability test on a fine sand, the following data are given. We have the length of a specimen, the diameter of a specimen, constant head difference, the volume of water collected in 4 minutes is 420 cubic centimeter, and then the void ratio of the soil specimen. And we are required to determine the coefficient of permeability in centimeter per seconds, the discharge velocity in cm per seconds also, and then the seepage velocity in centimeter per seconds. So first one is the hydraulic conductivity, and the formula of hydraulic conductivity for a constant laboratory test of permeability is QL over AHT. So lahat na yan binigay. Dahil kapag sinabing laboratory test ng permeability, usually yung mga problems dito, direct substitution. Ang magiging problema na lang natin mismo ay yung consistency of units. So kailangan yung bantayan mismo yon. So substituting, we have K is equivalent to Q. Q is the volume collected sa ating test, and that is given 420 cubic centimeter multiplied by the L, length of the specimen, also given 16 cm, over A, the cross-sectional area of the specimen, given yung diameter, therefore circular mismo yung cross-section ng ating specimen. In the area of circle is pi over 4 d squared. Diameter is 9.6 cm quantity squared, multiplied by H, the head loss, given also 50 cm, multiplied by T, that is the duration of the test, and that is given also 4 minutes. So, tingnan natin yung units, cancelled yung cm. This is cubic centimeter, square centimeter, cancelled cm per minute. But, coefficient of permeability should be in cm per seconds. So, convert natin mismo yung minutes into seconds. That is multiplied by 60 seconds is to 1 minute. Cancelled. So, okay na yung units natin. So, computing for the value of K, we will get 0.002 0.077 centimeter per seconds. And that will be our first requirement. Our second requirement is discharge velocity. Ang ibang term na ginagamit sa discharge velocity is superficial velocity. So, parehas lang yung dalawang yun. So, we have discharge velocity. That is the product of coefficient of permeability and hydraulic gradient I. But, hydraulic gradient I is the ratio of the head loss with respect to the length of the soil specimen. So, substituting now, we have discharge velocity equivalent to K, already computed, 0.077 or 0.077 centimeter per seconds, multiplied by H, head loss, given in the problem, over the length of a specimen, 16 centimeters. So, computing for discharge velocity, we will get a value of 0.024 centimeter per seconds. And then the last requirement is to determine the seepage velocity in centimeter per seconds also. Another term for seepage velocity is interstitial velocity, true velocity, and actual velocity. So, pare-parehas lang mismo yung apat na terms na yon. And then, seepage velocity is the ratio of discharge velocity with respect to the porosity of the soil. But then, walang porosity na given. But we can relate yung porosity sa void ratio ng soil specimen na binigay sa problem. Because porosity is equivalent to E over 1 plus E, wherein E is the void ratio of the soil. So, substituting now, seepage velocity will be equivalent to discharge velocity, already computed, per seconds, over E, void ratio of 0.55, over E, or 1 plus E, 1 plus 0.55. Computing for seepage velocity, we will get a value of 0.068 centimeter per seconds. And these are the requirements for the problem regarding constant laboratory tests for permeability.